Hello! In this video, I will be explaining how I conducted this lab on making a concentration series of solutions. As you can see, I made 5 solutions, all of which have varying concentrations. I used glass cups in order for you to clearly see the colors in each solution. So I started off with the first solution, which we can call the mother solution, which is on the far left here. I added a packet of 4.5 grams of Kool-Aid into the glass. I was able to calculate the mass of the Kool-Aid by simply looking at the packet as it indicated that it was 4.5 grams. Next, I calculated the molar mass of sucrose sugar. Now, the reason why I chose to calculate the molar mass for sucrose was because I'm assuming that Kool-Aid is made up of mostly sugar. So the chemical formula for sucrose is C12H22O11. So I calculated the molar mass by taking carbon 12.01 and multiplying that by 12, hydrogen 1.01, multiplying that by 22, and oxygen 16, multiplying that by 11. I added them all together and got the molar mass of 342.34 grams per mole. Next, I found the number of moles of the solid by using the unit factor analysis method. So I took the mass of the solid, 4.5 grams, and multiplied that by 1 mole over the molar mass, which is 342.34 grams per mole. This gave me a total of 0.013 moles. Then I added 150 milliliters of water to the Kool-Aid solid to give me a solution of the liquid water and the Kool-Aid solid. Next, I calculated the molarity of the mother solution by taking 0.013 mole and dividing it by 150 milliliters. However, I had to convert from milliliters to liters, so I went from 150 milliliters to 0.150 liters. So in turn, I have 0.013 mole divided by 0.150 liters, which gave me a total of 0.086, which serves as the molarity for the mother solution here. So next, I transferred 25 milliliters from the mother solution into cup number 2. And then I added 150 milliliters of water into cup number 2. So the dilution equation for this would be 0.086, the molarity of the mother solution, multiplied by 25 milliliters, the amount transferred from the mother solution, divided by 175 milliliters, which is the total number of the solution after adding 25 milliliters of solution 1 as well as 150 milliliters of water. So after calculating that gave me 0.012, which serves as the molarity of solution number 2. Next, I transferred 50 milliliters from solution number 2 into cup number 3. I then added 150 milliliters of water. The dilution equation would be as follows: 0.012, the molarity of solution number 2, multiplied by 50 milliliters of solution number 2, divided by 200 milliliters, which is the total amount transferred from solution number 2, which is 50 milliliters, and 150 milliliters of water. This gave me a total of 0.003, which serves as the molarity of solution number 3. Then I transferred 75 milliliters from solution number 3 into cup number 4. I also added 100 milliliters of water. The dilution equation is 0.003, the molarity of solution number 3, multiplied by 75 milliliters, the solution from cup number 3, divided by 175 milliliters, which is the total amount transferred from solution number 3, 75 milliliters, and water, 100 milliliters. This gave me a calculation of 0.001, which serves as the molarity for solution number 4. The final step was to take 100 milliliters from solution number 4 and transfer it into cup number 5, and add 200 milliliters of water to cup number 5. The dilution equation would give me 0.001, the molarity of solution number 4, times 100 milliliters, the amount taken from solution number 4, divided by 300 milliliters, which is the total amount of water in solution from cup number 4. That gave me a total of 0.0003 molarity of cup number 5. Now the goal of this lab was to dilute the mother solution to a concentration of parts per million by the time you got to the 5th solution. However, I was unsuccessful with that. But if I were to continue, I would continue diluting the solutions further for about 5 more steps, and I think that would allow me to reach a parts per million value. Thank you so much for watching. I hope you enjoyed my lab.